HelpMeWithStats.com was used to create this tutorial that can help us calculate a power, 2 tails. Let's work through a problem calculating the power of an experiment. The population mean is given as 100 and the population standard deviation is 12. There are 16 people, and we are using a two-tailed hypothesis test with an alpha level of 0.05. If we assume the alternative population mean is 107.23, what is the power of this experiment? Let's start by remembering that power calculations use mean distributions. Mean distributions are thinner than score distributions by a factor of the square root of the sample size. The width of the mean distribution, the standard error, is the standard deviation of the scores divided by the square root of the sample size. In this example, the standard error is the standard deviation of 12, divided by the square root of 16. This works out to 12 divided by 4, the square root of 16, which is 3. Next, we need to find how far the means of the two mean distributions are away from each other. This is called the effect size. We know that the absolute distance between the means is 107.23 minus 100 equals 7.23. But we need to know this effect size in standard errors, which is called the SE. The SE is 7.23, the absolute effect size, divided by the size of the standard error, 3. The SE works out to 7.23 divided by 3, which is 2.41. Since the power of an experiment is the part of the alternative distribution above the critical value of the null distribution, we need to know what the critical value is given the number of tails and the alpha level. With 2 tails and an alpha level of 0.05, we can look up the critical value and find it to be 1.96. Now that we have the critical value, we need to find what the area of the alternative distribution is above the critical value of the null distribution. We need to find the z-score of the null distribution critical value on the alternative distribution. We calculate this value by first multiplying the SE by -1. We do this because the null distribution is SE standard errors below the alternative distribution. Next, we add the critical value because the critical value is above the mean of the null distribution. In this example, the null distribution is 2.41 standard errors below the mean of the alternative distribution, so the mean of the null distribution has a z-score of -2.41. We add the critical value of 1.96, which gives us -0.45. The critical value of the null distribution has a z-score of -0.45 on the alternative distribution. We find the area above the critical value of the null distribution, because that is the definition of power. We use the normal distribution tables to find the area above -0.45, which is 0.674. The power of the experiment is 0.674, which is the probability of correctly rejecting the null hypothesis. For more help with statistics, HelpMeWithStats.com is a free website that has more than 70 tutorials, as videos, or as self-paced slideshows. You can also learn how to conduct more than 60 statistical analyses by watching videos that show complete solutions, or by working through an unlimited number of examples using the step-by-step problem solvers. Finally, you can access a comprehensive stats textbook with more than 685 review questions. Thanks for watching. If you find these resources valuable, please share with your friends, teachers, and professors.